Hey guys, this is lesson 4. This is going to be the last new information for our next test. We're going to look at similar characteristics among function families, differences, and kind of figure out which one is which. So I want to remind you, we know what functions look like. We know that our linear functions, they can go up or down. They're straight lines. Exponentials have a curve. They're either going up or they're going down. And then the quadratics are the ones that look like a U, either facing up or facing down. So if we describe things, which function families could this be? If it's got a smooth curve, that could either be exponential or quadratic, okay? The graph is made up of a straight line. That has to be linear, okay? The graph increases or decreases over the entire thing. So this is saying it either does one or the other. That has to be an exponential, or it can be linear. It doesn't say it has to be a curve, but if you'll notice, both my exponential and my, and let me point at this. Where is it? Both my linear and my exponential either go up or down or up. But with your quadratics, they change directions. So exponential or linear has an absolute maximum or an absolute minimum. That's your quadratics. Because with your linear, it could go up to infinity or down to infinity. Same thing with exponential. But this guy, the quadratics, they either have that top dot or they have the bottom dot. So that's going to be, your quadratics. Okay? One or more characteristic has been added. The graph has an absolute minimum or absolute maximum, and it's a smooth curve. That sounds like has to be a quadratic. It either increases or decreases, and it's a straight line, and it's a straight line. That has to be linear, okay? Has a smooth curve, either increases or decreases over the entire domain. Since it says curve, that tells me it's exponential because it either does one or the other. It can only go one direction. That's exponential. Okay, we're going to go back and revisit some of the scenarios that we did in the very first lesson that we did. Remember the music club and the fishy and all the aquarium and all that good stuff? Okay, so the domain, we're going to talk about the domain, the range. Or actually, I guess we're going to do the domain and we're going to do... we're going to talk about some different stuff. First of all, I'm going to say that this music club, if this was really real world, this should not have been a straight line, or excuse me, a continuous graph. This really should have been a discrete graph. So I'm going to do it in black. Shame on whoever wrote this textbook, because when she had her number of songs and the dollar value, you would not connect these lines. You can't buy 1.5 songs. Our domain would have been 0 songs, 1 song, 2 song, 3 song, 4 songs, etc. Okay? So if I was going to find my domain in the real world, remember domain is the x-axis, and I would draw a vertical line, and I'm going to do my domain with my vertical line, and I'm going to say, well, this graph starts at the number 0. So the smallest number of songs that she could buy is 0. But in reality, guys, the arrow kind of does help me understand that she can buy as many songs as she's got money for. So technically that could go to infinity or as many songs as they have. But I want you to understand that it's really just whole numbers. But it's going to be anything above 0. But it's going to have to be whole numbers only. Therefore, that's why we're going to put it in set and list it this way, okay? Because it's really not a continuous domain. Now, the range, I'm going to go ahead and talk about it. The range is the same thing. You can pay $0, $1, $2, $3, etc., okay? The graphical behavior, this is an increasing graph because it's going up. Now, this is clearly a decreasing graph. And this is that something fishy. And I don't know if you guys remember, but it started with 200 gallons of water. Now, This is a continuous graph because over time, as the minutes pass by, the tank is dropping and dropping and dropping continuously. So if I was to take my little friend, my vertical line test over, or my little vertical line, and I start at the time of 0, as the time goes on and as the time goes on, this aquarium is going to keep dropping and dropping and dropping. So when I ask you what the domain is, the domain is going to be anything from, let's go back over to where it started. What's the smallest value on my graph? It should be 0 for the x value. Let's make this line to pick up, okay? 0 for my x value because my domain is down here on the x-axis. This would have been time 0 when we start moving the water, okay? And after a minute, it's dropped 10 gallons. After 2 minutes, it's dropped 20 gallons. So it goes to 190, 180, 170, 160, 150, 140. Eventually, guys, are we going to run out of water? Yes. So however long it takes, and I do believe if I divided 20 divided by 10, I believe it's going to take 10 minutes to drop the gallons of water, if I remember that problem right. But if you were just looking at this graph, you would have to say that the domain is x is greater than or equal to 0, all times greater than or equal to 0. But in reality, I want you to understand that eventually it's going to run out and there will be a right boundary in this problem. This is a decreasing graph. Okay, this next one, my domain. Okay, my domain, again, you're looking at your x values, and this guy was this was the person with the phone. And we started out at $0, and over time we owe our cousin more and more and more and more and more. So technically, the way you're looking at this graph, x is greater than or equal to 0, but I'm assuming at some point we're going to have this thing paid off, so really we're not going to go to like infinity, but the graph is going to infinity. This is an increasing graph. Now, go back and name the graph types, which I suppose I should have done. This was linear. This was a decreasing linear. This was an increasing linear. I'm sorry, not linear. Did I really just do that? This was an increasing exponential. Okay. We've got some more graphs. This one is a decreasing exponential. This next one is an increasing and then decreasing quadratic. This is a decreasing, then increasing quadratic. Okay. And I'm not going to beat the domain and range to death because we're going to be doing some better examples of domain and range later on. So let me see if I can find one in here. Okay. This is a really good one that we're going to do domain and range on. So I'm on page 69. So if I want to do the domain, okay, first of all, this is a quadratic. Can everybody see that this looks like a quadratic? I can see it has an absolute minimum. Looks like its absolute minimum is right here at 4. But the big idea is I want to go do the domain and range. So here's domain. I'm going to draw that. Domain, remember, is my x. I'm going to go draw my straight line. And I'm going to figure out what's my lowest x and what's my highest x as I move left to right on the graph. So here we go. Oops, let's move the whole thing, please. Okay, so my lowest x, it looks like is even with 0. So I'm going to put a 0 for my lowest x. And then I'm going to move over to the right side of the graph. Where's my highest x? Well, now the highest x, I'm touching an arrow. An arrow means it is not limited. That's like saying to infinity, there is no boundary. It's positive infinity. So normally we would put our little less than or less than symbols, And then since the one on the left was a solid dot, basically since it was not an open dot, it's a solid dot, I am going to underline the symbol on the left. And then the infinity, guys, that really means there's no boundary. I don't need to worry about it. So all I really need to worry about is 0 is less than or equal to x. But they're not going to write it that way. They're always going to write the variable first. So flip it around to where you're writing x first. And do you see how the wide side of the symbol is closest to the x? I'm going to make my wide side of the symbol closest to the x when I flip it around. Still going to underline, and I'm going to put the 0 on that side. So ladies and gentlemen, my domain is x is greater than or equal to 0. Any number you can come up with that's bigger than or equal to 0. Now I'm going to go look at range. For range, you are only allowed to get your numbers from the y-axis. And we are going to go from top to bottom of the y-axis, okay? So I'm going to flip my little line, make it horizontal, make it perfectly horizontal. It's harder than it looks. Okay, I'm going to go move it. So I'm going to start at the bottom of the graph. The lowest point I have on the graph is even with, y'all see that 4 over there? You see how it's even with this 4 right here? Okay, so 4 is the bottom end. Y is the middle. We're talking about all the graphed points. And now I'm going to take my picture and I'm going to move it up to the top. Now, I'm not going to stop at the arrow because there's stuff above that. But I've got this guy right here, and it looks like it's 16. But you got to be careful on this one. Because while it looks like, yeah, 16 is the greatest thing, here is what I need you to remember about that arrow. That arrow is going to keep going, isn't it? So what is really at the top of this picture? At the top of this picture is really this goofy arrow. So at the upper end, there really is no boundary. See how that one was kind of tricky? It's positive infinity. So we're going to draw our symbols. We're going to remember that down here at the bottom, that is not an open dot. That was just the line touches at 4. So, or equal to. We're not going to worry about the infinity sign, but I cannot leave it 4 is less than or equal to y. I have to flip it around. So instead, I'm going to put the y on the left side. I need the wide side of the symbol closest to the y. Put the or equal to and the 4. The range is everything greater than or equal to 4 for y values. Okay. We are going to, I'm just going to continue using these graphs to demonstrate. Oh, and by the way, we said this was a quadratic. Okay. This next one, this is linear. It's increasing. But I'm going to demonstrate domain and range because that's a good thing to demonstrate with this. So I'm going to start with domain. Domain. I'm going to highlight my x-axis. I'm going to get my pencil, or in y'all's case, you're going to watch me with my little vertical line that I'm going to draw. Okay? I'm going to move the vertical line over to my graph. The smallest x value I see is 0. X will be in the middle. Now I'm going to go find the biggest x value I see. So I'm going to move my vertical line. When I get over here, oh, look, it's an arrow. That means infinity, right? So this thing goes to infinity. Now, this thing touched at 0, so I'm going to say x is less than or equal to, because it did touch at 0. The only time you're not going to put the or equal to is if you see a circle on the end of your picture like that. That you would just put the symbol with no equal to symbol on it, okay? But we didn't. We had the whole thing. So I'm going to erase that. There we go. And we're going to ignore the infinity side of the problem. Don't need to worry about the infinity side because that's not really a boundary. And we're going to flip it back around where x is first. The big side of the symbol was closer to the x. So I'm going to put the big side of the symbol closer to the x, put the or equal to, and put the 0. Now I'm going to go do range. Here's my range. Okay. Range is the y-axis. I'm going to go take my cute little line, and I'm going to make it horizontal. I'm going to move it over. I'm starting at the bottom, and it looks like my bottom y is going to be 0. So 0, then y. Let's see how high it goes. Well, it goes to an arrow, doesn't it? So if I come up to the top, the highest y I see is an arrow. That means infinity. We don't worry about infinity. That's not really a boundary. We draw our symbol, but again, I can't leave it facing that direction, so I'm going to flip it around. Y needs to be sitting next to the big side of the symbol because that's the way it was when I wrote the inequality. And so here's my domain, here's my range, okay? Hopefully that's making a little more sense to you guys. And I'm not going to do the lesson 4 assignment. There is an Eduphoria assignment for you guys to practice these skills.